What are aragonite and calcite saturation states? Have you ever wondered how the chemistry of ocean water affects marine life? Today, we will discuss aragonite and calcite saturation states and their significance in the Arctic Ocean. These saturation states are key indicators of the chemical conditions in seawater. They tell us whether aragonite and calcite, two forms of calcium carbonate, can form, stay stable, or dissolve. Marine organisms, especially in polar regions, relying on calcium carbonate to build their shells and skeletons. This includes shell-building plankton, mollusks, and corals. The saturation state is represented by the Greek letter omega. It measures the actual concentration of carbonate ions in seawater compared to what is needed for these minerals to be stable. When the omega value is greater than 1, the water is supersaturated. This means aragonite or calcite can form or remain just stable. Conversely, when the omega value is less than 1, the water is undersaturated, leading to the dissolution of these minerals. Aragonite is more soluble than calcite. This means it becomes undersaturated at higher pH levels and lower carbonate ion concentrations. Therefore, the aragonite saturation state is a sensitive indicator of ocean acidification, especially in polar waters. In the Arctic Ocean, aragonite saturation states can vary significantly. For example, surface waters in the western Arctic Ocean have shown omega values ranging from below 1 to above 2. Areas like the Chukchi Marginal Area often experience undersaturation, while the East Siberian Marginal Area tends to have higher saturation due to biological production that increases carbonate availability. Seasonal melting of sea ice and increased absorption of carbon dioxide from human activities lower the saturation state. This makes the water more corrosive to aragonite-based shells. This is concerning because undersaturation has been observed in the Canada Basin. This is linked to sea ice retreat and the upwelling of deeper, more corrosive waters onto the continental shelf. The calcite saturation state behaves similarly but usually remains higher than the aragonite saturation state. This is because calcite is less soluble. Both saturation states are essential for assessing the health of calcifying organisms in polar marine ecosystems. Monitoring these saturation states in polar regions is vital for tracking the progression of ocean acidification. Declining saturation states indicate increasing acidification, which threatens the ability of organisms to maintain their calcium carbonate structures. This could disrupt food webs and ecosystem functions in these sensitive environments. Understanding aragonite and calcite saturation states helps us grasp the ongoing changes in our oceans and their impact on marine life.